Good evening, students. Today we are going to discuss the topic linear differential equation. First, we have to consider the general form of linear differential equation. The general form of linear differential equation is dy by dx plus py equal to q, where p and q are functions of x or constant terms. P and q are functions of x or a constant terms. Next, we have to consider the general solution of this linear differential equation. First, we have to multiplying both sides by e raised to integral p dx. That is multiplying throughout by e raised to integral p dx. Therefore, this linear differential equation becomes dy by dx into e raised to integral p dx plus p into e raised to integral p dx y equal to q into e raised to integral p dx. Now here dy by dx into e raised to integral p dx plus p into e raised to integral p dx y. This is of the form d by dx of y e raised to integral p dx. That is, here we have to apply the product rule, the derivative of first function into second function plus first function into derivative of second function. Next, integrating on both sides. Integrating on both sides, we get integral d by dx of, this can be written as derivative of y e raised to integral p dx. That is, it is the product rule. Derivative of first function into second function plus first function into derivative of second function. Then RHS equal to integral q e raised to integral p dx dx. Now here integral d by dx of y e raised to integral p dx. That means here integral d by dx of, here both operations will be appearing, integration and differentiation. Therefore, the result is what? Y e raised to integral p dx equal to integral q e raised to integral p dx dx plus c. This is the general solution of the linear differential equation dy by dx plus py equal to q. Here, e raised to integral p dx is called the integrating factor. Integrating factor. Therefore, the general solution is y into integrating factor equal to integral of q into integrating factor plus c. That is, here e raised to integral p dx is called the integrating factor of this linear differential equation. Next, consider the question. Solve x into dy by dx plus y equal to x cube. First, we have to change this equation into linear differential equation. That is, it is of the form dy by dx plus py equal to q. Now here, the given question is x dy by dx plus y equal to x cube. Now here, we have to divide throughout by x. That is, dy by dx plus y by x equal to x square. Here, p equal to what? 1 by x, that is dy by dx plus py equal to q. Now here p is 1 by x into y, that is 1 by x is p and q is equal to x square. Next we have to find out the integrating factor e raised to integral p dx. It is equal to e raised to integral 1 by x dx. That is equal to e raised to log x. Integral 1 by x dx is log x. That is e raised to log x is equal to x. Therefore, the general solution is what? Y into integrating factor. That is, y into integrating factor is what? E raised to integral p dx is x. Y into e raised to integral p dx equal to integral q e raised to integral p dx dx plus c. It is the general solution. Then substituting here, e raised to integral p dx is x and q is equal to x square. Therefore, the general solution y into x equal to integral x square into x dx. Now here xy equal to integral x cube dx. Therefore, xy equal to what? Integral x cube dx is x raised to 4 by 4 plus c. This is the general solution of the given linear differential equation. Next question, solve dy by dx plus y by x equal to log x. Now here it is of the form dy by dx plus py equal to q. Here p is what? Here p is equal to 1 by x and q is equal to log x. Therefore, the integrating factor e raised to integral p dx, it is equal to e raised to integral 1 by x dx. That is equal to e raised to integral 1 by x dx is log x. That is equal to what? E raised to log x equal to x. Next we have to find out the general solution. General solution is y into e raised to integral p dx equal to integral q e raised to integral p dx plus c. Here e raised to integral p dx is x, that is y into x equal to integral, here q is log x and e raised to integral p dx is x. Therefore, it will be taken as log x into x dx plus c. Next, integral log x into x, that is integral of first function into second function. Here we have to take first function log x into integral of second, integral of x is x square by 2 minus integral of derivative of first function. Here first function is log x. Therefore, d by dx of log x is 1 by x. 1 by x into integral of second function. Integral of x is x square by 2 dx. Therefore, it is equal to 1 by 2 into x square log x minus here x cancelled. Therefore, 1 by 2 into integral x dx. It is equal to 1 by 2 into x square log x minus 1 by 2 into integral x square dx, that is x square by 2 plus c. Therefore, xy equal to 1 by 2 x square log x minus 1 by 2 x square by 2 plus c. Here 1 by 2 is common, therefore we have to take outside. Then how can write? Therefore xy can be written as 1 by 2 into x square log x minus x square by 2 plus c. Here 1 by 2 is common, therefore we can take outside 1 by 2 into inside the bracket x square log x minus x square by 2 plus c. This is the general solution of this linear differential equation. Next question, solve y dash plus y cot x equal to cos x. Here y dash is dy by dx. Therefore, it is of the form linear differential equation dy by dx plus py equal to q. Here we can change this one as dy by dx plus y cot x equal to cos x. Now here p equal to what? Here p equal to cot x and q equal to cos x. Then next we have to find out the integrating factor, that is e raised to integral p dx. The integrating factor equal to e raised to integral p dx, it is equal to e raised to integral cot x, that is equal to e raised to integral cot x is log sin x. Therefore, e raised to log sin x, integral cot x is log sin x. Therefore, e raised to log sin x is sin x. Then next we have to find out the general solution. General solution is what? Y into integrating factor, that is y into e raised to integral p dx equal to integral q e raised to integral p dx plus c. Y into e raised to integral p dx equal to integral q e raised to integral p dx plus c. Now here e raised to integral p dx is sin x. Therefore y into sin x equal to what? Integral. Here q is cos x. Cos x into e raised to integral p dx is sin x dx. We know that sin 2 theta is equal to 2 sin theta cos theta. Now here we can considering sin 2x. It is equal to, instead of theta we can take x. Therefore sin 2x equal to 2 sin x cos x. Therefore sin x cos x equal to 1 by 2 sin 2x. Therefore sin x cos x can be written as sin x into cos x equal to what? 1 by 2. 1 by 2 into sin 2x. Therefore, we can change this integral as 1 by 2 into sin 2x. Therefore, y into sin x equal to integral 1 by 2 sin 2x dx. Then it is equal to, here 1 by 2 take it as outside, integral sin 2x dx. Integral sin 2x is minus cos 2x by 2. It is equal to 1 by 2 into minus cos 2x by 2 plus c. That is y into sin x equal to what? 1 by 2 into minus cos 2x by 2 plus c. Therefore, our general solution is what? Y sin x. Now here minus 1 by 2 into 1 by 2, that is minus 1 by 4. Take it as this side, therefore plus 1 by 4 into cos 2x equal to c. This is the general solution of the given linear differential equation. Consider the question. Solve the differential equation dy by dx plus y tan x equal to x square cos square x. First question, find the integrating factor. Then second question, solve the differential equation. Solve this differential equation. Here, first you have to consider it is a linear differential equation. Therefore, dy by dx plus py equal to q. Now here, in this question, p is, here p equal to tan x and q equal to x square cos square x. Next, we have to find out integrating factor. Here, integrating factor is equal to e raised to integral p dx. That is equal to e raised to, here p is tan x. Therefore, integral tan x dx. It is equal to e raised to log sec x. Integral tan x is log sec x. Therefore, e raised to log sec x is equal to sec x. Therefore, the integrating factor is sec x. Next, we have to solve this linear differential equation. Therefore, the general solution is what? General solution is y into e raised to integral p dx equal to integral q e raised to integral p dx plus c. Here e raised to integral p dx is sec x. Therefore, substituting here y into sec x equal to integral q e raised to integral p dx. Here q is what? X square cos square x. Then integrating factor is sec x dx. Therefore, y into sec x equal to, here x square cos square into sec x. Therefore, sec x can be written as 1 by cos x. Therefore, it can be changed into integral x square cos square x into 1 by cos x dx. Here cos x cancel. Therefore, it is equal to integral x square cos x dx. Therefore, y sec x equal to integral x square cos x dx. Y into sec x equal to integral x square cos x dx. Next, it is equal to, here integral of first function into second function. Here first function is x square. Therefore, first function into integral of second, integral of cos x is sin x minus integral of d by dx of first function. Here d by dx of x square is 2x into integral of second function, that is integral of cos x is sin x dx. It is equal to x square sin x minus 2 into integral x sin x dx. That is equal to x square sin x minus here 2 into, then next here we have to apply integral of first function into second function. Then how can I considering here first function is x, therefore x into integral of sin x is minus cos x minus integral of d by dx of first function. Here d by dx of x is 1 into integral of second function, that is minus cos x dx. It is equal to x square sin x minus 2 into minus cos x. Here minus 2 into minus cos x x. Therefore plus 2x cos x. Then minus 2 into minus of minus cos x. That here minus of minus plus. Then again minus 2. That is minus 2 into integral cos x dx. It is equal to x square sin x plus 2x cos x minus integral cos x is sin x. That is equal to minus 2 sin x plus c. Y into sec x equal to x square sin x plus 2x cos x minus 2 sin x plus c. This is the general solution of the given linear differential equation. Next question. Find the general solution of cos x into dy by dx plus y sin x equal to tan square x. First we have to change this one into a linear differential equation. Now here cos x into dy by dx plus y sin x equal to tan square x. It can be changed into dy by dx plus py equal to q. In this case, dy by dx, the coefficient is cos x. Therefore, we have to divide this equation throughout by cos x. Therefore, dy by dx plus y sin x by cos x equal to tan square x by cos x. Then it is equal to dy by dx plus y sin x by cos x is tan x equal to tan square x into 1 by cos x is sec x. That is tan square x by cos x. Therefore, tan square x into 1 by cos x, that is 1 by cos x is sec x. Here p equal to what? Here p equal to tan x and q equal to tan square x sec x. Next we have to find out integrating factor. Integrating factor e raised to integral p dx, that is equal to e raised to integral tan x dx, that is equal to e raised to integral tan x is log sec x. Therefore e raised to log sec x, it is equal to sec x itself. Therefore here the integrating factor is sec x. Next we have to find out the general solution. General solution y into e raised to integral p dx. The general solution is what? Y into e raised to integral p dx equal to integral q e raised to integral p dx dx plus c. Now here e raised to integral p dx is sec x, that is y into sec x equal to integral, here q is what? Tan square x into sec x into, then again e raised to integral p dx is sec x dx. Therefore integral tan square x into sec x, it is sec square x dx. It can be changed into sec square x dx. That implies integral tan square x into sec square x dx. Next, we have to substitute t equal to tan x. Then dt by dx equal to what? Sec square x. Therefore, dt equal to sec square x dx. That is here we have to apply substitution method. Put t equal to tan x. Therefore, dt by dx equal to sec square x. dt equal to sec square x into dx. Then substituting here. Therefore, this integral becomes, that implies y into sec x equal to what? integral tan square x into sec square x dx. It is equal to, put tan is equal to t. Therefore, integral t square into dt. Here sec square x dx is dt. That is equal to what? Integral t square dt is equal to t cube by 3 plus c. Here t what? Tan x. Therefore, tan cube x divided by 3 plus c. Therefore, y into sec x equal to what? Tan cube x divided by 3 plus c. Therefore, 3y sec x equal to what? We have to take 3 this side. Therefore, the general solution is 3y sec x equal to tan cube x plus c. This is the general solution. Next question, solve the differential equation x into dy by dx equal to x plus y. First, arranging this equation in the form dy by dx plus vy equal to q. That is here throughout divided by x. Therefore, dy by dx equal to what? 1 plus y by x. Therefore, dy by dx minus y by x equal to 1. Here, p equal to what? Minus 1 by x and q equal to 1. Next, we have to find out the integrating factor. The integrating factor equal to e raised to integral p dx. That is equal to e raised to integral minus 1 by x dx. It is equal to e raised to minus log x. That is equal to e raised to log 1 by x. Therefore, e raised to log 1 by x is equal to 1 by x. Next, general solution. The general solution is what? Y into e raised to integral p dx. That is y into 1 by x equal to integral. Here q is 1. Q into e raised to integral p dx. That is q into e raised to integral p dx is 1 by x. Q is 1 and e raised to integral p dx is 1 by x. Therefore, 1 into 1 by x dx. That is y by x equal to integral 1 by x dx. That is equal to y by x equal to what? Integral 1 by x is log x plus log c. Here the constant we can take it as log c. That is y by x equal to log x plus log c. Now here y by x equal to log x plus log c. That means y by x equal to what? Log of log a plus log b. That is equal to log ab. Therefore, it is equal to log cx. Then next, y by x equal to log cx. Now here, this y by x can be written as log e raised to y by x equal to log cx. Now here log e raised to y by x, the value will be y by x itself. That's why we can change this y by x in terms of log, that is log e raised to y by x. Then equating LHS and RHS, we will get e raised to y by x equal to cx. E raised to y by x is equal to cx. This is the general solution of the given linear differential equation. Next question. Solve 1 plus x square dy by dx plus y equal to tan inverse of x. First, we have to change this into a linear differential equation form. Therefore, here we have to divide this equation by 1 plus x square. That is dy by dx plus y by 1 plus x square equal to tan inverse of x divided by 1 plus x square. Here, p equal to what? 1 by 1 plus x square and q equal to tan inverse x by 1 plus x square. Then next we have to find out the integrating factor. Then integrating factor equal to e raised to integral p dx, that is equal to e raised to integral 1 by 1 plus x square. That is 1 by 1 plus x square is tan inverse of x. That is e raised to integral 1 by 1 plus x square. 1 by 1 plus x square is equal to what? E raised to tan inverse of x. Integral 1 by 1 plus x square is tan inverse of x. Therefore, the integrating factor is e raised to tan inverse of x. Then next we have to find out the general solution. That is y into e raised to tan inverse of x. The integrating factor is e raised to tan inverse of x equal to integral, here q what? Tan inverse of x divided by 1 plus x square into, again, here the integrating factor is e raised to tan inverse of x dx. Next, put t equal to tan inverse of x. Here we have to apply substitution, t equal to tan inverse of x. Therefore, dt by dx equal to what? 1 by 1 plus x square. Dt equal to what? 1 by 1 plus x square into dx. That is 1 by 1 plus x square into dx is dt. Therefore, this integral will be integral tan inverse of x is t. That is t into e raised to tan inverse of t. That is e raised to t. Then into 1 by 1 plus x square into dx is dt. That is y into e raised to tan inverse of x equal to integral t e raised to t dt. That is first function t, then second function is e raised to t. Therefore, the integral of t e raised to t, first function into integral of second function e raised to t minus integral of d by dt of t, that is 1, that is d by dt of first function. Here first function is t, that is 1 into integral of e raised to t dt. That is equal to t e raised to t minus next integral e raised to t dt. That is equal to t e raised to t minus integral e raised to t is e raised to t plus c. Now here e raised to t is common, then take it as outside e raised to t into t minus 1 plus c. That is y e raised to tan inverse x equal to e raised to t into t minus 1 plus c. Next, we have to substitute t is equal to tan inverse of x. That is here substitute t is equal to tan inverse of x. Therefore, e raised to tan inverse of x into tan inverse of x minus 1 plus c. That is y into e raised to tan inverse of x equal to what? E raised to tan inverse of x into tan inverse of x minus 1 plus c. This is the general solution of the given linear differential equation. Next question. Find a particular solution satisfying given condition dy by dx plus 2y tan x equal to sin x, y equal to 0 when x equal to pi by 3. Here, first we have to find out general solution of this linear differential equation. Then next, we have to find out an arbitrary constant c by using the condition when x equal to pi by 3, y equal to 0. Then after that, we will substituting the value of c in this general solution, we will get a particular solution. That is here, in this linear differential equation, p equal to what? Here, p equal to 2 tan x and q equal to sin x. Integrating factor equal to e raised to integral p dx, that's equal to e raised to integral 2 tan x, that's equal to e raised to 2 into integral tan x, that is equal to e raised to 2 into integral tan x is log sec x, log sec x, that is e raised to 2 log sec x means what? E raised to log sec square x, that is equal to sec square x. Therefore, the integrating factor is sec square x, that is e raised to 2 log sec x can be written as e raised to log sec square x, that is equal to sec square x is the integrating factor. Therefore, the general solution is y into sec square x e raised to integral p dx is sec square x equal to integral, here q is what? Sin x into integrating factor is sec square x dx. Then it is equal to here integral sin x by cos square x, that is sec square x can be written as 1 by cos square x, that is equal to 1 by cos square x can be written as sin x by cos x into 1 by cos x dx. It is equal to, that is 1 by cos square x can be split into sin x by cos x into 1 by cos x. That is equal to sin x by cos x is tan x, that is integral tan x into sec x dx. That is y sec square x equal to integral tan x into sec x. Therefore, y sec square x equal to integral sec x into tan x or integral tan x into sec x dx is sec x plus c. Next, we have to consider 1 by cos x equal to sec x. Therefore, the sec square x can be changed into 1 by cos square x and sec x can be changed into 1 by cos x. Therefore, y into 1 by cos square x equal to 1 by cos x plus c. Therefore, y equal to what? Here, the cos square x by cos x, that is cos x, that is cos square x by cos x plus c into cos square x, that is equal to cos square x by cos x, that is cos x plus c cos square x. Y equal to cos x plus c cos square x. Next, we have to find out the value of c, that is the arbitrary constant. Here, the given condition y equal to 0 when x equal to pi by 3. That is substituting here y equal to 0 equal to cos x value will be pi by 3 plus c into cos square pi by 3. That implies cos pi by 3, the value will be cos 60 degree 1 by 2. That is 1 by 2 plus c into cos square pi by 3, that is 1 by 2 square. This equal to 1 by 2 plus c by 4. Therefore, c by 4 equal to minus 1 by 2. Then c equal to, that implies c equal to minus 4 by 2, that's equal to minus 2. Therefore, this general solution will be changed into what? Y equal to cos x minus 2. Here c is minus 2 cos square x. That is y equal to cos x minus 2 cos square x is the particular solution of the given linear differential equation. Next question. Find the equation of the curve passing through the point 0, 2, given that sum of the coordinates of any point on the curve exceed the magnitude of the slope of the tangent to the curve at the point by 5. We know that the tangent of the curve is dy by dx. Therefore, the sum of the coordinates of at any point, that is, let us consider x and y are the two coordinates, then the sum of x plus y equal to what? Here the given condition is exceeding the magnitude of the tangent to the curve at that point by 5. Therefore, here we know that the tangent of the curve is dy by dx plus exceeding at the point 5. Therefore, the given condition is x plus y equal to dy by dx plus 5. That is the sum of the coordinates x plus y equal to what? Dy by dx plus 5. That is exceeding the magnitude of the tangent of the curve at the point by 5. Now here, first we have to change this one into a linear differential equation. Therefore, how can we change? Dy by dx minus y equal to what? X minus 5. That is, this is of the form what? Dy by dx plus py equal to q. Here, p equal to minus 1 and q equal to x minus 5. Therefore, the integrating factor e raised to integral p dx equal to what? E raised to integral minus 1 dx, that is equal to e raised to minus x. Therefore, the integrating factor is e raised to minus x. Therefore, the general solution y into e raised to minus x equal to integral, here q what? X minus 5 into e raised to minus x dx. That is equal to, here the first function is x minus 5, second function is e raised to minus x. Therefore, first function into x minus 5 into e raised to minus x, integral e raised to minus x is e raised to minus x by minus 1 minus integral derivative of the first function d by dx of x minus 5, that is 1 into integral of e raised to minus x. Integral of derivative of x minus 5, that is 1 into integral of e raised to minus x, that is e raised to minus x by minus 1 dx. Therefore, y e raised to minus x equal to x minus 5 into e raised to minus x divided by minus 1, that is minus of, then minus, here minus integral e raised to minus x divided by minus 1, that is plus integral e raised to minus x dx, that is equal to minus of x minus 5 e raised to minus x minus, here integral e raised to minus x is e raised to minus x divided by minus 1, that is e raised to minus x divided by minus 1 plus c, that is equal to minus of x minus 5 e raised to minus x minus e raised to minus x plus c. That is y e raised to minus x equal to minus of x minus 5 e raised to minus x minus e raised to minus x plus c. Y e raised to minus x equal to e raised to minus x common, take it as outside, then minus x plus 5 minus 1 plus c. E raised to minus x, take it as outside, therefore minus of x minus 5, that is minus x plus 5, then here minus e raised to minus x, here e raised to minus x, take it as outside, therefore the remaining is minus 1 plus c. Therefore y e raised to minus x equal to 5 minus 1, 4, that is 4 minus x into e raised to minus x plus c. Next, multiplying throughout by e raised to x, multiplying throughout by e raised to x, that is y equal to, here e raised to minus x into e raised to x, that is e raised to 0, therefore LHS is y equal to 4 minus x into, here e raised to minus x into e raised to x, that is e raised to 0, the value will be 1 plus c into e raised to x. Then next, consider the condition, the curve passing through the point 0, 2, we have to find out the particular solution. That is when x equal to 0, y value 2. That is 2 equal to what? 4 minus 0 plus c into e raised to 0. That is equal to e raised to 0. The value will be 1. Therefore, 2 equal to 4 plus c. That implies 2 equal to 4 plus c. Therefore, c equal to what? C equal to 2 minus 4 equal to minus 2. Put the value of c equal to minus 2 in equation y equal to 4 minus x plus c raised to x. Therefore, the particular solution is y equal to 4 minus x plus minus 2 e raised to x. That is, therefore, y equal to 4 minus x minus 2 e raised to x. This is the particular solution.